I've given talks in this room before, and I know you're not going to get it really dark, and I'm not going to try to have really flashy pictures as a result. Mostly the pictures are up there to remind me of what I'm supposed to say next. And it starts with the title I've been given, Big Questions in Astronomy. I don't promise you big answers. As you guys who are scientists know, the purpose of science is not to come up with answers, but to come up with bigger and better questions. And the big questions that I'm going to deal with, there are a number that I'm going to touch, some that I'm not going to get to. But I took the topic in the broadest possible sense, and I'm really going to be talking in some degree about big questions in cosmology. For that, since I'm not myself a cosmologist, in the pecking order of astronomy, there are the people who do cosmology far away in space and time, and the people who do rocks and planets, and that's where I am at the other end. So I've relied on a number of other people, the late Bill Stager, who is one of the great lights of the Vatican Observatory for many years, died of cancer 2 years ago, sadly. And Paul Gabor and Paul Muller. And I'm not telling you these names out of humility. God knows I'm very proud of my humility, but no one else can find it. I'm doing it to cover my rear end so that when I make horrific mistakes, I can say, it's all your fault, Paul. Blame him back there. He was supposed to correct me. After I... Yeah, he does try. He is very trying. After I put this talk together, I suddenly realized this would be a perfect time to advertise that you can actually get 12 big questions from the Now You Know media people. I hope you know these guys. It's kind of like the university podcasts, 25-minute lectures. And this particular outfit specializes in Catholic topics. There's a lot of retreat material. It's great. And I'm told this is good. I was in a total daze because it was right after our province congregation, and they put me in front of a microphone, and 2 days later they said, thank you. I have no idea what I said, but it's available. And the last thing, along with this card, which is a little bit of advertising, which has some addresses so you can find us again later on. Because people want to know a bit about the Vatican Observatory, I thought I would show you a short 5-minute film which has people who can explain the Vatican Observatory far more eloquently than I can. Both science and religion are conversations about the universe. They're ways of learning how we interact with this universe. It's not simply a question of, is there a God, but there is a God, now what do we do? It's not just a question of, there are a bunch of stars, but rather, why are there stars? How do they work? How does that tell us how things work here on Earth? The interaction that I see in my own life is that religion gives me the reason to do the science.
Back in the papacy before Francis was Benedict, and one of his lines in a final elocution to the fathers of the General Congregation was, go to the frontiers. Well, there isn't much more frontier than 3.7 billion years away.
The first official interest of the Church for astronomy started in 1582 with the reform of the calendar. Then in 1891, Pope Leo XIII wanted to have an observatory to show that the Church is not against science, but the Church promotes good science.
They start up by having telescopes on the Tower of the Winds, and then on the walls surrounding the Vatican, as the city lights grow, and as the Italian government gives them back the territory out in Castel Gandolfo. In the 30s, they build new telescopes on the roof of the Papal Palace in Castel Gandolfo, best telescopes of their era in the 1930s. By the 1980s, light pollution makes those telescopes unusable, so we build a new telescope in the dark skies of Arizona.
I'm Father Jean-Baptiste Kikwaya Eluo. I'm working in 3 projects. The first one is NEOS, Near Earth Object. So what I'm doing with NEOS is just observe them using our modern telescope VAT. The second project is meteors. I worked on very faint meteors, what we call shooting stars. And the third project is set fireball network. They will have 4 cameras here around Tucson so that actually we can monitor any fireball getting into the Earth atmosphere in the region.
This telescope, the Vatican Advanced Technology Telescope, it was the first of the new technology telescopes that has been considered pretty much the norm now in developing telescopes. With the advance of computer technology, we have the capability of bringing that advanced technology directly into our telescope. So it's an expandable, it's almost like it's a living machine, so it can grow as technology grows.
It is still very important to maintain scientific research at the Vatican, simply because there is still a lot of confusion about this relationship between science and faith. We are not out here trying to prove the existence of God by looking through a telescope. That's not what we're doing. But we can say that if we want to obtain any reasonable results looking through that telescope, we need to do it embracing a certain work ethics that is, in fact, the same work ethics that the Bible itself tells us through commandments and through the Gospels to embrace.
Human beings look at the stars and wonder. They want to know, what is that? What is that about? How do I fit in? They hear about the moon landing and they want to know, what was that like?
Very well.
If we're part of the human race, we're part of the race that went to the moon. We're part of the species that looked at the stars and wondered, what the heck are those things? Looking at the sky reminds you that there's more to the universe than what's for lunch. What's more, if you believe in a universe that God so loved that he sent his son, then not only are you going to want to study the universe because it's kind of cool, it's an act of worship. It's an act of getting closer to the Creator and getting closer to a universe, as St. Athanasius said 1,500 years ago, was cleansed and quickened by the Incarnation. Then, doing science is an act of worship. So I want to talk about cosmology, and what I mean by cosmology is the sum of the assumptions we make about how the universe works. Because I think the big questions that come out of astronomy is that astronomy has shaped the questions and our concept of both the size of the universe, both in space and in time, and the shape of the universe. The way it's put together, the way that the pieces fit together. Our understanding of cosmology has changed radically over time. And if you start with the idea of a flat Earth and a dome, you're going to have a completely different idea of the universe. But our idea of the past is also shaped by the filter of the intervening periods, because in fact that's not a medieval view of the universe. That's a Victorian misapprehension of the medieval view of the universe. And when we speak to those who are not specialists in the field, they have the assumption, well, the medievals thought the world was flat. They have the assumption. We know, if you know your medieval ideas, there are about 12 things wrong with that picture that makes it not medieval. First of all, they knew the world was round. Secondly, they didn't have the sun and the moon and the stars all in the same dome, even back in the days when they thought it was a dome. They certainly didn't have the mechanism behind it. It's clearly a 19th century representation. And we're dealing with people in the 21st century who are still imbued with the assumptions of the generations previous. Here. How many, you're all Americans, basically. Most of you grew up in the United States. A few of you didn't. A good question to ask your kids. Ask your audience, whoever they are. When you were a kid, were you taught that Christopher Columbus proved the world was round?
Yes.
Did you ever question that statement even as a kid? Wait a minute, he didn't even make it all the way around the world. How did he prove anything? Where did that piece of mythology come from? It actually came out of the 19th century. It came out of a lot of anti-church. Well, those Catholics thought the world was flat, but Columbus proved he was. Total nonsense. We have a couple of people here who are not raised in the United States, not educated in the US. Were you taught that Christopher Columbus thought the world was round? Okay. A lot of Europeans did not. It's mostly an American, a US-centric misapprehension. But it's part of our cosmology. There was, of course, a time when people thought the world was flat. And if you want to understand why anyone would think that, walk outside. You can see Tucson is on a flat plain. As far as you can see, there are mountains at the edge, and there is a dome overhead, which you can see for yourself. And go out and look at the stars at night, and you can see that the stars are in a dome. And I don't care how many doctorates you have, when you walk outside and you look at the stars, they're a dome. That's what you can see. If you look a little bit longer, especially in the morning, there are 5 planets visible at about 6 in the morning. Go out and take a look for them. They're the ones that don't twinkle. Because they move separately, each planet is in its own dome. Years ago, I was invited to give a talk to a group of Native Americans about meteorites, the things I study. And I said, meteorites are rocks that fall from the sky. And one of the women in the group goes, which sky? Because likewise, their cosmology had varying levels of sky. Well, of course, we know now, as the ancient Greeks know, that the world is round. You can see it from the round shadow the Earth makes during an eclipse. And yet, even today, in our language, we have a number of assumptions about the universe in the words we use. For most languages in the West, Romance languages in particular, the word for sky is the same as the word for heaven. And that's going to shape what people think of as, where is heaven, what is heaven? In all of our cultures, every culture I've come across, up is good and down is bad. We're going to, ask for a higher power. You ever say, let's go ask for a lower power? We're getting a higher education. I'm moving up in the world. Because of the cosmology that we live in, the astronomy that was the common sense from 3,000 years ago, that things up there are pretty and good, things down here are muddy and dirty and icky, and if you don't believe that the center of the earth is the inferno, I'll take you to an island and I'll show you the fire and brimstone in a hole in the ground, in the island of Volcano. By the time of the ancient Greeks, they recognized that the earth was round and it was surrounded by spheres with the other planets, still multiple skies. And the firmament beyond is still, beyond the primum, was where God dwelt. Another common Enlightenment misconception is that people in these days thought the earth was the center of the universe. If the earth is the center of the universe and therefore a privileged place, but the inferno is at the center of the earth, that would make hell the most privileged place in the universe. Obviously, that was not the way they thought. The earth is the bottom of the universe. It's the lowest place, only one step above the inferno. It's the place where things fall apart, where even the pyramids rust, whereas the stars and the planets move in constant and never-dying motion, but certainly not unchanging motion And so to explain the motion of Mars itself, which can appear to move in one part of the sky and then move back and then move forward again, Eudoxus had this series of nested spheres. Now these are not spheres of different planets. These are all the spheres associated with Mars. Every sphere is moving. Well, what makes a sphere move? A sphere moves. Things move on Earth, unless, except for falling and rising, fire rising and smoke rising and things falling. That's natural motion. Every other motion is the motion of life. That's why the wind has life, has anima. The same word for wind is the word for soul, is the word that we get the word animal from, is the word for breath. Built into the cosmology, the assumption we make without even recognizing we're making it about the universe. Now, if every sphere is moving, every sphere has a planetary intelligence. And that's why the astrologers could say, well, it's very, very difficult to calculate because I have to figure out not just where Mars was, but where each of those other spheres was moving to figure out, which anima was moving that sphere. And the spheres would communicate with each other by exchanging little information packets they called demons, which those of you who do Unix programming will recognize the term. Another word for demon was genius. So that if you're born when that sphere was inducing the genius of music onto the sphere below, you got a little bit of it, and that's why you're a musician. There was also a genius for sleep, which I'm pretty good at that. At the same time, well, from our point of view at the same time, this is Eudoxus, this is about 300 BC, around 150 AD, AD 150, Ptolemy comes up with a completely different way of describing the planets in terms of circles and circles within circles and circles within circles within circles, which he used as a calculating device to be able to determine the positions of the planets. Why would you want to do that? Because he was the Neil Silver of his day. He figured out, if astrology works, and I can tell you where the planets are going to be, I can predict who's going to win the election, what the stock market's going to be, are we going to have good crops or bad crops? And if I could do this really well, I can make you money. So pay me and give me the research and I'll figure it all out. We'll have it all mapped out. But of course it also means that the universe is totally determined by the positions of the stars. If you look into the Hebrew scriptures, you will find in several places strong arguments to not follow the astrologers, to not follow the people who say that the planets are more powerful than God, that basically the planets null out our free will. It doesn't mean that they didn't believe that's the way the universe worked. You can find beautiful pictures of the zodiac in ancient synagogues. But there was this religious conflict between the science that everybody knew, that the universe seemed to be determined by the positions of planets, and the theology they were taught, a theology of free will. These are not new questions. In fact, there was a bit of a conflict that in the time of St. Augustine, so that when Augustine is writing on the literal interpretation of Genesis, he warns, and this is a quote, which is why I've got this up here, even a non-Christian knows something about the earth, the heavens, the other elements of the world, about the motion and the orbit of stars, and even their size and relative positions, about predictable eclipses of the sun and moon, the cycles of the years and the seasons, and with this knowledge, he holds to it as being certain from reason and experience. Now, it is a disgraceful and dangerous thing for an infidel to hear a Christian, presumably giving the meaning of Holy Scripture, talking nonsense about this subject. So even he had his fundamentalists. That said, you'll notice that as we went from the flat earth of Genesis to the enclosed circles of Aristotle, to the many, many spheres of Eudoxus, to even the Ptolemaic circles within circles within circles, none of which looked like Genesis, none of which is described that way in Scripture, there was no Galileo crisis. People happily moved from the one to the other. And the way they did that was through an image that C.S. Lewis talks about in this wonderful book, The Discarded Image. The image that you could assign to the realms of the universe a parallel realm of metaphysics, so that the spirits that were moving the planets were no longer planetary intelligences or the gods, but rather ranks of angels. If there were 7 movable planets, there are 7 planets, you know. Pluto is not among them. So what are the 7 planets? The Moon, the Sun, Venus, Mercury, Venus, Mars, Jupiter, and Saturn. Why do we know there are 7? Because there are 7 days of the week named for those planets, which in Romance languages is very obvious. Lunardy, Martedi, Micolidi. In English, of course, we've got Saturn Day, Sun Day, Moon Day, and the other days of the week named for the German gods that associated themselves as the same ones. You know, Woden's Day, Thor's Day, Frida's Day. This unified picture, C.S. Lewis writes, is of course underlying all of the culture, the cosmology. C.S. Lewis was not an astronomer. He was not even a historian of science. He was, you know, his day job was to teach Renaissance and medieval literature. And you can't understand Renaissance and medieval literature unless you understand the cosmology. And he wrote these lectures, which went into one of his last books, I think one of his best books, to help us get ourselves into the mood of what the Renaissance world looked like. Of course, Lewis is mostly famous today for writing which books? Narnia. 7 of them. And each one associated with a planet, according to Michael Ward and his very powerful thesis on Planet Narnia, which I recommend just as an amusing thing to read. At the end of it, at the beginning of it, you're going, yeah, right. And at the end of it, going, well, maybe. And in the meantime, it allows you to read the Narnia books with a much greater depth than you might have seen otherwise. But his goal in the Narnia books, according to Ward, was to get the reader inside this medieval view without realizing that that's what they were doing. The cosmology that the astronomers are bringing to us is nonetheless going to be in conflict with the cosmology of the language that we grew up with in a universe that's now spheres within spheres within spheres. Up doesn't have the same meaning. Higher doesn't have the same meaning. To say that I'm going to go and search for an education that is a greater radius from the Earth education doesn't cut it the same way that a higher education does. Astronomy and the cosmology of astronomy already is tugging at, is straining within the constraints. Because, as Lewis says, it was one of the most glorious descriptions of the universe that only had one problem. It was not true. And it was even before modern science that people were recognizing problems with the physics of the time. So there's a list of a number of the great thinkers of the medieval era. Maimonides, the rabbi, who points out that time could very well have a beginning, unlike what Aristotle talks about. Bishop Tempier, in 1277, was trying to stop the philosophers and the theologians from fighting each other at the University of Paris, and made it illegal to teach things such as theology is worthless because Aristotle's got it all figured out, which meant that people were given license to challenge and question Aristotle. Buridan talking about momentum, Nicholas Arim talking about the relative motion of earth and sky. There's a wonderful passage in Arim where he says, from logic alone, you cannot tell whether it's the earth standing still and the stars moving, or the stars standing still and the earth is moving. Because it would look exactly the same as far as the motion of the stars to the earth. 1377. Pretty good, huh? He then goes on to say, of course everybody knows the Earth is standing still. This just shows you the limits of logic. That it could lead you to think something as absurd as the idea that the Earth is moving. Think of these arguments when you hear people trying to cleverly adopt modern science, 2016 science, to philosophical questions. By the time of Copernicus, there was a great challenge. But you have to remember, Copernicus himself didn't have that nice picture, which is in the frontispiece of his own book. How many people here read Scientific American? You're familiar with Scientific American. When I was asked once to write a Scientific American article, which I never did, I was told the important thing is to have a good title, because people will read the title, good figures, and good figure captions, because that's most of what people will read. And it was certainly true in the case of Copernicus's book. He's got a wonderful picture at the front of the sun and then all the planets and circles around the sun. That's not actually what his model was. His model included epicycles. Even the sun itself was doing a little circular dance around the center. He needed that to be able to calculate correctly the positions of the planets. As a calculating device, the Copernican system had the advantage of having one fewer term. It had the same inaccuracies, which could be solved by having more and more circles in your epicycles. The real genius of the Copernican system, the only reason the Copernican system was better than the Ptolemaic system, was that by moving to a sun-centered system, 200 years later, Newton could come up with a new physics to explain things. That would not have happened with the Ptolemaic system. It's not a case of one fitting the data better than the other. Fourier's theorem says if I have an infinite number of circles, I can make the Ptolemaic system work just fine. But it doesn't lead me to a deeper insight into how the universe works. There's the difference. In fact, people recognized the Copernican system as being superior when time came for the reform of the calendar, and Christopher Clavius, S.J. I remind my lay audiences what S.J. stands for. People don't know the Jesuits so well, so it's super genius, right? When the reform of the calendar occurred, at the time of the reform, on the walls of St. Peter's, in one of the buildings that you can actually see today from the Vatican Museum, on top of one of the museums, is a room called the Tower of the Winds, because a number of winds were painted on there. On the south wall, there's a little poteau with poteau, I guess it would be one of them, with a hole in his mouth. The sunlight comes, crosses the meridian line, and you can work out not only when the moment of noon is, but from where it crosses the line, you can work out your latitude and longitude, and also when the beginning of spring occurs or the beginning of fall. This was built in 1582. A lot of people say, that's how they reformed the calendar. No, they knew about that. The reform itself came out in 1582. It was built mostly as a way of demonstrating to the world, yes, we know what we're doing. We can show you why the calendar needed fixing. And the calendar, of course, ultimately is just a numerical formula for calculating Easter, which Clavius in his book works out so that if you go to 2016 in his book, you can determine that Easter is going to be on the 17th of March. He got it right, because we're still using that formula. If you go up about 4 years earlier, he gets the date of Ash Wednesday wrong by a month. So even this book has typos in it. The Catholic world, the educated world, was very aware of Copernicus's cosmology and Copernicus's work, but even though Copernicus himself in the book states that this is meant to be his understanding of how the universe works, most people used it just as a calculating device for the very good reason that it didn't match all the observations. In particular, if the Earth were moving and stars are at varying distance, then when the Earth moves from one part of the sky to another, a nearby star should appear to move relative to the far stars. So that from here you think that nearby star is in front of the 3 there, from here that nearby star is going to be in front of the other two. In order to make this argument work, you had to know how far away the stars are. Well, there were two ways you could calculate the distance to the stars. The first is you look at the brightness of the star. You assume, like the moon, that they shine by reflected sunlight. And if you say they're going to be that bright, they can't be all that far away unless they were enormously big to be as bright as we see. An absolutely correct calculation based on a false assumption. But that's what science does all the time, is comes up with assumptions. Our cosmology is our assumption. There was another way that Galileo eventually comes to, which I'll get to in a minute. Because one does not see this parallax motion, the only possibility is that the Earth is not moving relative to the stars. And yet, the Copernican system was so elegant in many other ways, so Tycho Brahe comes up with a system that suggests the Earth stands still, the sun is still going around the Earth, but all the other planets go around the sun. And from observations of the planets and themselves, you cannot tell the difference between the two systems, because mathematically they're identical, they're the same system. You've just moved the origin point. This is a cosmology that was not inconsistent so much with the basic physics of Aristotle, though it certainly had a little bit of problem when you're trying to say, are the other planets still having influences on us? There was still, during the time of Copernicus and 100 years later, the time of Tycho Brahe and Johannes Kepler, the idea that you wanted to make the universe, the physical universe, mirror the metaphysical universe. That was still the assumption of its time. And the big question for astronomy then was, what can we learn about the metaphysical universe, assuming it is a mirror of the physical universe? Kepler ran it backwards. Kepler, who was the guy who came up with the elliptical orbits, had a cosmology that said the sun, S-U-N, the brightest and most important thing in the sky, is clearly in the place of God the Father. The light coming off the sun would be the Holy Spirit. Now, the trouble with Copernicus, he's got the sun in the center, but the sun is still moving. How can I come up with a mathematical way of describing the motions of planets that allows the sun to be fixed? And his answer was elliptical orbits. He accepted the idea that planets move in ellipses with the sun being in a common focus, out of a metaphysics that insisted that the sun had to be like God and therefore fixed and therefore not moving. He also writes in his book, which was written in this incredibly turgid Latin, but only Job Karantaram, an Indian, has learned enough Latin to be able to paw through it. I love this. He was the guy who taught me philosophy of science at the University of Chicago. He writes in the same book, we all know that truth cannot be derived from false principles. Obvious statement of philosophy. Obviously wrong, because he came up with the elliptical orbits, assuming the false premise that the sun could not be moving. The other big change, though, that occurs at this time is the invention of the telescope in Galileo. With Galileo's telescope, he's able to confirm the idea that the inner planets, Venus and Mercury, show phases and therefore must be moving around the sun, and why can't all the other planets be moving around the sun, which was not opposed to what Tycho Brahe's idea was. But more shockingly, he observes little stars moving around Jupiter, which he names the Medicean moons, and for the first time, he's showing motion of things around something other than the Earth, still compatible with the Tycho Brahe system. But what was more incompatible was the idea that he is observing things that the ancients didn't know. He got into a big fight with a Jesuit, Orazio Grassi, about the position of comets. And there was a sort of an internet war, a Twitter war back and forth between the two of them, as each of them was writing pamphlets, until finally Galileo writes this marvelous book, The Assayer, which has this blurb in the front in long poetry about how wonderful Galileo was. What did the church think about it? The church censor says, "I believe our age is to be glorified by future ages, thanks to the deep and sound reflections of this author, in whose time I count myself fortunate to be born." This was an answer to the Jesuit Grassi, so of course the censor he gets is a Dominican. Galileo was honored by the church for, good 15, 20 years. What happens to him eventually? Why, I've got a book. I've got 2 books. I've got 5 books to recommend. You can go on Amazon.com and come up with 400 different books about what really happened to Galileo. All of them telling you a different story, and all of them showing that they're right and everybody else is wrong. I love history. Among the answers you'll get range from the ones I have in quotation marks, which I think are pretty easy to refute. A tragic conflict of worldviews. Like, that's a lovely sounding phrase, but what the heck does it mean? The church is always afraid of new... No, it isn't afraid of new ideas. It was a particularly fearful time because of the Protestant Reformation, which, remember, led to world wars. He was a secret atomist. Well, there are lots of people who will find one letter or one document and say, aha, this is the key to it all. That's bad science. I don't know how that works in history, but if you hang your theory on one data point, I get to be, very, very worried. It is certainly true, however, that he made a lot of personal enemies. Hey, he was an Italian scientist. It's the way we do things. His book was personally insulting to the Pope. I think that's a pretty fair argument to make. The conflict came to a head right at the height of the 30 Years' War, and there are some people who would argue that the history of the 30 Years' War affects what went on in the Galileo trial. I mean, if you were to tell somebody that an event occurred in December 8th, 1941, you'd be nuts to not think that maybe Pearl Harbor didn't affect the attitudes of what was happening at the time. If you were to tell somebody that an event occurred during the week of September 11, 2001, I think we all know that, yes, the politics happened. The Galileo trial occurs right at the height of the 30 Years' War, right at the time when King Gustavus Adolphus looks like he's about to conquer everything and start to invade Italy. And there's a tremendous conflict between the Spanish side, the Italian Pope, who's been elected with French help, and the French are secretly supporting the Protestant side. Could it be that the Galileo trial is tied up in all of that? Yeah, maybe, maybe not. What isn't there is the idea that the church is anti-science. Indeed, the church continues to work in science and support science with the astronomical book of Riccioli, a member of the Society of Jesus, writing in 1651, which has arguments for and against the Copernican system, and also includes the map that we still use today for the moon with the nomenclature we still use today, and the most prominent crater on the moon, named by Riccioli, is crater Copernicus, 20 years after the Galileo trial. And this work was among the work taken by Berbiste and the others who went to China to show the superiority of Western thought over Chinese astrology. One other person to symbolize the last point I want to get to in this talk, even though he's not himself an astronomer, was Athanasius Kircher, who was a fascinating character. He arrives in Rome the year that Galileo goes on trial, when he's 30 years old. He teaches mathematics, Hebrew, Syriac, made machines, observed volcanoes. He worked out connections between the Coptic and ancient Egyptian languages. He organizes a museum of marvels. He's got things that he thinks are unicorn horns. Well, they're not unicorn horns, but he thinks he's got them. He is in that wonderful realm between the old and the new. He writes a 3-volume work on Noah's Ark. mapping out how it could be possible mathematically for an ark described in the Bible to have enough volume to feed the animals that the ark must have. Now, we can laugh, but notice what's going on. He's taking medieval ideas and addressing them with mathematics. What did we hear last night about how mathematics was the source of truth? Most of his work, when we read it today, reads like utter nonsense. But it's nonsense groping towards the truth in a way that, in fact, is an important way of reaching the truth. He was one of the key figures in the 17th century. Before there were scientific journals, the first scientific journal, the Philosophical Transactions, is 1665. Before then, if you're a scientist, how do you get your work out? You write to certain nodes of knowledge. He was one, Mersenne was one, Robert Hooke was one. People, you'd write to them, and then they'd spread it out to their circle of friends. And so he was an important key in the way science was done. I cite the C.S. Lewis book. Lewis has a point which is almost correct. Maybe the reason why Copernicus didn't raise a ripple and Galileo did was that one was just using it as a calculating device and the other said this was real. We know that's not true. Copernicus himself, when you read the Copernicus book, says this is how I think the universe actually works. What I think the difference is that Galileo wrote in the vernacular. He was on the talk show circuit. He, had a great Facebook following for his era. He was someone out to publicize the ideas. Virtually the same time as Galileo, well 20 years earlier, is Gilbert in England, who writes on many of the same ideas, but doesn't cause a scandal because Gilbert writes in Latin and says in his books that these popularizers, these people who show up on TV all the time, they're fake scientists, don't think about them, don't pay attention to them. Our real scientist writes in Latin for scholars. We see the same, I grew up in the field of Carl Sagan, and I saw how badly Carl Sagan was treated by his contemporary planetary scientists, because he was on TV all the time. You can't be a real scientist and be on TV. Of course, if you want me on TV, I'd be happy to. What is going on in the scientific revolution? What's going on with the idea that suddenly Galileo is discovering things that the ancients didn't know is another radical change in cosmology that has nothing to do with the positions of planets, but has everything to do with how we think about knowledge itself. And this is all stuff I'm stealing from Paul Gabor, so if you disagree with me, complain to him. He points out 3 fundamental shifts that are occurring in the scientific revolution. A change in the Golden Age mentality, I'll get to that, the role of instruments, and the standard of proof. The stories that everyone is growing up with are stories that say, in the past things were wonderful, something terrible happened, now things are terrible and will never be as good as we once were. We had a paradise and we lost it. There was an Atlantis and it disappeared under the oceans. If you don't believe that, and you're a medieval or even a Renaissance person, and you're living in Rome, you're surrounded by the wreckage of the Golden Age that you have no idea how were they ever able to. Ancient aliens came and built it. They might as well have believed that, only they thought that the ancient aliens were their ancestors, and that somehow we can never do what the Romans were able to do. That's why books had such authority. Because given the fact that things are invariably getting worse, if you can hold on to a little bit of knowledge from the olden times, the older the book, the more precious it is, because the closer it is to the days when people actually had it all figured out. The best we can hope for is to approximate what the ancients were able to do. Because even though I read your book, I'm never going to be as smart as you are. Besides which, writers and books are themselves rare. They're relics of a lost golden age. And therefore, anything that's in a book is trying to tell you something, and if it contradicts something that's in another book, well, that's just because I'm too stupid to be able to figure out how to make them work, because books are the source of this perfect knowledge. And that's even in the phrase of the two books, the book of nature, the book of scripture, still has that mentality that books are relics of a knowledge that we will never be able to have. C.S. Lewis had two quotes. It was an age of authority. Every writer bases himself on an earlier writer. Of course, we as scientists never have to cite previous sources. Well, we're doing it, but we're doing it in a different way now. They're credulous of books. They find it hard to believe that anything that an old author has said maybe just might be wrong. The ancient scrolls. This is Jesus reading from the scroll of Isaiah. Finding a book that was lost is like finding something that was once known but forgotten. In a sense, it's like refreshing the memory of an old person who's beginning to forget things, so that every day you have to remind them, but as they're getting older, they're getting more feeble. And as the human race is getting older, it's getting more feeble. And it's got to have little notes that say, today is Friday, that you leave on the table for your mom to read, so she remembers what day it is in the morning. That's what books are to the human race. We know it's futile. We know that eventually we're going to decay. Even though a few select people might be able to be almost as good as the ancients. Civilizations rise, but they always fall. And each rise is a little bit less than the previous one. Learning is the only worthy exercise, but if you manage to recall a truth from the past, you will have a touch of the divine in the days when we were able to walk in the garden with God. Even the Renaissance was all about trying to recover the knowledge of the past. We may not be able to have a golden age, but at least we can have a silver age. I was supposed to say something, but I have no idea what that was. The metaphor of this way of thinking is degeneration. Things are always getting worse. Contrast that with our modern metaphor, growth. An economy has to be growing to be any good. Our knowledge has to be growing. In the past, knowledge gradually faded through the centuries as things gradually decay, just like the pyramids decay. Remember that, everybody knows things were better in the good old days. Galileo's contemporaries still had this idea that time started with the Golden Age and humanity was going inexorably down a path of deterioration. What does Galileo do? He's revealing something that no Golden Age book ever talks about. He's seeing things that no one had ever seen before. Does this make a splash? Shakespeare has a late play, I forget which one, one of you will remind me, where it's based on classical themes, and Jupiter shows up close to the end of the play with 4 attendants.
Pericles.
Yes, Pericles. The play is written 2 years after Galileo's book comes out. Trust me, everybody knew. The modern myth, everybody today knows that people in the past were ignorant savages who thought the world was flat. That civilization accumulates knowledge slowly and painstakingly, and science is the way that we become superior to those stupid people in the past. This is the 19th century Whig idea. This change in how we think of ourselves came about because of astronomy, originally. Astronomy was the place where for the first time we could see new knowledge, where for the first time we could test Newton's ideas and say, in a universe where there's no friction, things move exactly as Newton predicts. Something else, though, that Galileo did. Galileo was able to discover new things because for the first time you needed an instrument to see what he was able to see. Even today, most scientists using instruments have no idea how the instrument works. I've used data from mass spectrometers like that. I can describe in a vague sense what's happening inside the mass spectrometer. Could I wire one of these things up to work? No. Do we have one of these at the Vatican Observatory? Of course not. Not only can we not afford the $1 million to buy a machine like that, we certainly can't afford the $100,000 it takes every year to keep the technician employed to keep the machine running. Things have divided in that sense. G.K. Chesterton, contrasting the old and the new, has this very interesting, rather, as Chesterton would be, rather witty phrase from Orthodoxy. In fairyland, when you're asked why eggs turn into birds or fruits fall in the autumn, we answer exactly as the fairy godmother answers if Cinderella asks why mice turn into horses or her clothes fall from her at midnight. It's magic. Fairy tale language about things is simply rational and agnostic. It's magic. It's the man who talks about a law that he's never seen, the law of gravity. He's the mystic. There is, with the use of instruments, a divide between what the ordinary person can see for themselves, the very educated ordinary person can see for themselves, and what the expert who has access to these rare instruments can see. Out of the need to have instruments, we now have a different way of thinking about how knowledge is received, perceived, and passed on. What Galileo didn't... You can take a pair of binoculars out about midnight, Jupiter's pretty high up, and see Jupiter and see the 4 moons. Binoculars are good enough for that. A guy I know built his first telescope out of a kit with plans when he was 16 years old, did the entire thing himself, no grown-ups involved. He polished the mirror and he made it into a parabola and he built it in the tube and he wrote away for some eyepieces and he installed them and he described the first time he looked at Jupiter. And he was so disappointed because there was Jupiter, a nice big disk, but there were these little dots of light on either side of it, and he said, there must be a crack in the mirror. Where are these dots of light coming from? How did Galileo not know that the dots of light he was looking at were not just cracks in his lens? The idea of error being introduced by mistakes in the instrument was a new concept that was slow in coming to science. The idea that you can look through the telescope and see something very different from when you look through the telescope. Eventually, the astronomers talk about the personal equation of the observer. And this goes on to this day. This week, I'm involved in a big fight with the working group of planetary surface nomenclature over a series of features on Mars. Should they be called fossae or should they be called valleys? And 3 people insist, when I look at them, they look like valleys. And the other 4 say, no, 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 they're just linear cracks. We can't say, we're looking at the same objects with the same pair of eyes. But with my cosmology, my assumptions, I'm seeing different things than the person next to me is seeing. We come to the idea, this is related to the idea in the philosophy of science, all data is theory-laden. When you're taking data, you have an idea of what the answer is going to look like, because otherwise, how would you recognize the answer when you saw it? But the same data that were taken for one reason can be used 50 years later by a scientist who's looking at what you thought was noise and she thinks is signal. This concept of how we learn is a change that came out of the scientific revolution that originally came out of astronomy. Indeed, the early telescopes themselves weren't all that great. This is the lens of Galileo's first telescope from the museum, now called the Galileo Museum, originally the Museum of the History of Science in Florence. you can see that even though the lens is pretty big, the hole masks out the outer parts because the lens was not very good. Galileo had to make the lenses himself. Why did Galileo and not somebody else make, for that time, the best telescopes? He was in Venice. He could get good, clear, bubble-free glass. He had access to materials that other people didn't have access to. And even there, if anybody's tried using a small telescope, the telescope is about that long. I've seen it. I've got a little telescope. I'll tell you right now, my little telescope, lovely telescope, cost about $300. The tripod that it's on costs $300. Because if you don't have a steady tripod, the telescope is hopeless to use. Galileo had the telescope. He hadn't invented the tripod yet. And the way he fixed it and the way he could point in one direction or another was not always easy. After he goes and writes the book and becomes world famous, and he goes down and gets himself a job back in his hometown, he stops in Bologna on the way home. And he's got the telescope out and he wants to demonstrate it to people. Most of the people looking through the telescope are seeing that because Galileo focused it for his eyes, and his eyes were out of focus compared to most people's. He didn't know that. And what's worse, the telescope was mounted by dangling it from a tree, I understand. And so no one could even find the moon, much less see. As a result, one of Galileo's enemies writes a little book, a guy named Horky, saying, Galileo's a fraud. I've looked through his telescope. You can't see a darn thing through it. And he's telling the truth. Horky couldn't see a darn thing through it because it was out of focus and it was wobbling all over the place. Galileo's hope to get people to believe him was to sell as many telescopes or even give away as many telescopes so that everyone else could see what he was seeing and therefore be convinced that he wasn't telling a lie. But even after he makes the lenses and gives them away and gives people instructions on how to build them, they have to figure out for themselves how to mount it, how to focus it, where to look for it. It's a long while before enough telescopes are out there that people can finally convince themselves that what he's seeing isn't utter nonsense. The third, and I've run out of pretty pictures, so I'm just using this bullet points. The idea of what constitutes knowledge, what constitutes proof, changes radically with the mathematical scientific method. The Aristotelian standard was to be demonstrated, not to be merely probably true, but certainly true the way that a mathematical theorem is demonstrated. Truth is what's in mathematics. And that's what Galileo claimed, which of course he didn't have. The burden of proof was on the novel ideas. When Cardinal Bellarmine challenges him, he says, you know, until you can demonstrate to me that the Earth is moving, I'd much rather stick with the system that I've got that, you know, is time travel. And that's really what all of us do today. There are a dozen new theories to rival general relativity out there, and nobody but the theorists themselves are paying any attention to them because they're not demonstrably better than general relativity. But the standard for demonstrably better is different in the time of Aristotelian philosophy than today, where we say, all right, I can work out the probability that this works, and the probability is, you know, this theory fits the data better. But even there, we recognize that a theory is only adopted after enough time has passed that people have been able to use that theory to come to insights that the other theory doesn't provide. And sometimes you have more than one theory because each theory allows you insights. I think basically I've said what I wanted to say at this point. The last point is a change in the expectation of how the universe works. If every morning when you go out to feed the paper, you notice there's a cat that's sort of wandering around, and you leave a plate of milk out for the cat, and the cat comes up and licks the milk, runs away, you get your paper. The next day, you've got the bowl of milk out there, the cat comes out, fine. One day the cat doesn't show up. And you go, well, that's cats. If the universe is like a living entity, you expect it to not always behave exactly the same way. If the universe is a machine, then the fact that the cat's not there means, there must be a reason, there must be a cause, and you can work out a mathematical, It's a completely different, if you think the universe is a machine, then to attempt the same thing over and over and over, expecting a different result, is madness. But if you think that the universe is a living entity, then it makes perfectly good sense to hope that maybe the next time this will work. Our modern experience, which we'll go into in the next hour, is an interesting little bit of both. But there's clearly a difference between a universe that operates by whim and a universe that operates as a machine. At this point, time for coffee. Let's take a break and come back in half an hour. So a couple of two questions that came up during the break. One was the Shakespeare play was in fact Cymbeline.
That's right.
And not whatever it was we had said before. So, and the other, one person challenged me saying it wasn't just Galileo and astronomy that caused the change. Well, we could argue. I think Galileo and astronomy had a lot to do with it. And since I was supposed to talk about the big questions of astronomy, then I'm going to stick to my guns because it fits the story. Who cares if it's true? I want to bring up two other pieces. My schedule is, I'm going to desperately try to finish by 1:45, so we have 15 minutes for a conversation before going off to Mass at noon. And there are two other big questions that come up in astronomy. Incidentally, I promised that the size of stars and the distance of stars, when you look through at a star through a telescope, it looks like a disk because of the optics of telescopes. It's called the Airy circle. It's because of the wave nature of light. They didn't know that. They thought they were actually seeing disks of stars and calculated the distance to that star, given if it was like the sun, then this star must be, 4,000 times further than the sun is because it's 1/4000th the radius. Totally bogus. But it meant that they should have been able, if those distances were right, they would have been able to see parallax. They didn't see parallax. So either you said, the Earth isn't moving, or in the case of Galileo, who also noticed this, you say, I just won't publish that. He was a modern scientist. 2 points of big questions that come out of astronomy that will arise in the realm of faith and science. Places where astronomy challenges our ordinary way of thinking of ourselves are the things I want to cover today. And the first is, with the discovery of other worlds, and this is the frontispiece of a book by an Anglican bishop looking on life in another world. Kepler wrote a similar book. A fellow named Wilkins, who was the son-in-law of the guy who was not the king, Cromwell, Oliver Cromwell, or a brother-in-law, I think. There are a lot of books at that era that started saying, if there are planets and planets are the same as Earth, what about creatures on other planets? So that you've got the question, does God make other worlds? Now, there was a 13th century version of that, which would be similar to our question, are there parallel universes? The question takes on a new meaning. Are there other places within our universe where there could be other intelligences? So you've got William Durham writing in 1714 a book called Astrotheology that begins with the idea every fixed star is a sun and it has planets. It's a variation of what Nicholas of Cusa had written in the 13th century. Immanuel Kant raises this idea. William Herschel argues that there may be people living on the moon. what Herschel does, among other things, is maps out the brightness of stars and makes the assumption that stars are all the same brightness to work out their distance. In measuring stars, he comes to the realization that the stars in the sky appear to be in the shape of a disk. Well, the Earth is right there at the center of the disk because that's what he's seeing. But he is already seeing that you cannot assume the universe is uniformly filled with stars. This is a variant on Olber's paradox. The farther you look out, the more stars should be at that distance if all stars are uniformly distributed, because the radius of your sphere grows as r squared. The brightness of the star falls as 1 over r squared. So you should see equal brightnesses from all distances. And ultimately, no matter how far you look, you're going to be seeing a star, so the entire sky ought to be white. And it isn't. Therefore, there is some limit to the stars that we can see, and Herschel points out that it is in the shape of a disk. Eventually, with more observing, especially observing in the infrared, you can work out where we are. This is, of course, a picture of the Andromeda galaxy, our galaxy. It's impossible to have a photograph that shows our galaxy because we're inside the galaxy, right? Wrong. That is the Milky Way galaxy, taken by a composite over many years of high-resolution images glued together, taken from an observatory in the Southern Hemisphere, that's the European Southern Observatory. But you can see that we have a disk with a bulge pretty much where we thought the bulge was supposed to be.
That's a galactic selfie.
That's a galactic selfie, indeed. With a universe full of stars, what does this mean about the creation of God in man's image and likeness? Or to put it in a more crude way, but who would want to do that? And so notice the two authors who are in this room. So there are a couple of books, copies for sale in the bookstore. This is your chance to get them signed by both of us.
Autographs.
Autographs, but of course autographs are worthless. The idea of life existing elsewhere is not a new idea. It goes back to Lucian of Samosata in, it says 1909. Actually, it's 145, AD 145, I think. The ancients are full of stories, even on Earth, with other intelligent monsters, so that you can have a conversation with the sirens. You can have a conversation with the gods. You can have a conversation with all the creatures that Odysseus runs into. He doesn't worry about baptizing them. They all belong to the same religion. They're all pagans. It's very convenient. But even Scripture is not afraid to talk about creatures other than human beings in a relationship with God. When the universe is created, the stars sing for joy. In the early chapters of Genesis, the author borrows from the knowledge that everybody knows to talk about the monsters that he refers to as the Nephilim. And even if that isn't enough, we have creatures very different from human beings, but in our mythology have their own separate and very different story of redemption. We call them angels. Our tradition is not afraid to talk about creatures other than human beings. It's only really with the Enlightenment and the idea that if I didn't see it, it didn't happen, that there is a sense that it's foolish to talk about aliens, or the opposite, it's inevitable to talk about aliens, but we must talk about them in a way that conflates the cosmology of a universe in which Scripture was written, where the only place you expected to have human beings was on Earth, and God is the Savior, Jesus is the Savior of human beings, with a universe that's full of other creatures. There are two, even in the 17th and 18th centuries, there are two opposing ideas. One, the Reverend Pohl writing actually at the end of the 19th century, The universe must be filled with creatures because God is so creative. How could he do things any other way? Thomas Paine, writing 100 years earlier, goes and says, it's absurd to believe in religion, because given the fact that all these places are full of creatures, then, how do I phrase it? The unlikely proposition that of all the worlds in the universe, God chose to be incarnated only on ours because one man and one woman had eaten an apple, or there are so many incarnations that the person who is irreverently called Son of God would have nothing else to do than travel from world to world in an endless succession of death with hardly a moment to be alive. And he thought that was absurd. May not be quite as absurd as he thinks, and as Catholics we believe that the incarnation is repeated 1,000,000 times a day in the sacrifice of the Mass. But it does raise the question, a big question, that doesn't have a simple answer, yes or no, you must believe this, you have to believe that. What is the nature of Christ's salvation? There are parameters you can set. The salvation is for the entire universe. There is only one second person of the Trinity. There's not like one for each race that's out there. And yet, that still gives you wiggle room to say, if the Word became flesh among us, who's to say the Word isn't spoken in different languages? Or who is even to say that other species have to have a similar kind of salvation story as ours? Indeed, who is to say that our salvation story had to be the one we have of the suffering Messiah? There are predictions of other types of Messiah. You know, God could have appeared as an avatar in a cloud of thunder and lightning that no one's going to have any problem mistaking. That's not how God chose to do things. And isn't that telling you something interesting about God? The mere possibility of life elsewhere, we obviously haven't found it, but simply knowing that of the billion stars in a galaxy and the billions of galaxies that we have raises all sorts of wonderful big questions. When you ask, would you baptize an extraterrestrial? There are two fundamental questions you're suddenly dealing with. First of all, what is baptism? What is the nature of baptism? Is it just a way of saying you're in the club? And what does it mean to be alien? How alien is an alien? This is not the realm of theology. It is not the realm of science. It's the realm of science fiction. And I'm a big science fiction fan, as I mentioned last night. And it's not surprising that so many prominent science fiction and fantasy writers have been Catholics. Anthony Boucher was a prominent one in the 1930s and 40s. Of course, everybody knows of Tolkien. The guy in the middle, Gene Wolfe, still writing to this day, lives in the Chicago area, shows up to the conventions, and I've had the joy of being taken out to dinner. I tell you, working at the Vatican Observatory has perks. You know, Gene Wolfe asks me out to dinner. This is really cool. Wonderful, wonderful guy. Also, used to work at Procter & Gamble. I believe the story is he's the guy who invented the Pringles can. To keep the... Anyway, science fiction is where this is encountered. If there are other planets suitable for life, if there is life on those planets, if the life is intelligent, if the life is in a free, self-aware, loving relationship with the Creator, if that race can then communicate its experience to us, that's a lot of ifs. And if there's any one of those ifs that isn't true, the entire question becomes moot. And right now, we don't know if any of those ifs are true or not. That's okay. As I said, I'm not promising you big answers, but big questions. And it's a wonderful way to reflect on it, what it means to be human, human as compared to what? My favorite answer comes from Pogo. This is my favorite comic strip. If you can't read it, the porcupine, who's sort of the philosopher of Pogo, says, I've been reading about how there's maybe planets, people by people, with folks with advanced brains. On the other hand, maybe in all the universe, our brains are the most advanced. Either way, it's a sobering thought. Astronomy pulls us out of the flat Earth that we live in, with the dome overhead, where the only important question is the distance between me and the cup of coffee. And it makes us confront the reality that the universe is bigger than our own personal cosmology, than our own way of looking at the universe. Even if we argue about how to deal with that fact, no matter what bigger, more cosmic cosmology you're going to come up with, it's still going to be puny compared to the universe. You don't have to have the grand cosmology to be a saint. There were saints before Einstein invented general relativity. There's not a correlation between the two. But the humility that comes from knowing you don't know it all is married to the astonishment that we know anything at all. And yet clearly we do know something. My father has a marvelous tale that I've told many times. He says, knowledge is like an island. The more you know, the bigger the island. But the bigger the island, the longer the shoreline is, which is the boundary between what you know and what you know you don't know. So the more you know, the more you realize you don't know. Of course, if you think you know everything, it's because your island is really small. Maybe, of course, we're asking the wrong question about baptism, and this is what I'm stealing from Paul. Maybe the question is not would I baptize E.T., but would I share a meal with E.T.? If I saw E.T. by the side of the road injured, would I stop and help him? If I was by the side of the road, would I let E.T. help me? Would I die for an extraterrestrial? Would I let an extraterrestrial die for me? These are the questions of what it means to be in a relationship with each other and with something bigger than either of us. Another idea I'm stealing from Paul. Just as the sense that we were the center of the universe, because in the old medieval view, puts it the wrong way. The idea that somehow by being in a relationship with God, being baptized, being God's adopted children, makes us special as compared to the rest of the universe, has it backwards. One of the real important things that happens to you as a baby is when you recognize there are other babies. And the result is not a destruction of, oh, I thought I was special, but it's a joy in meeting and interacting and finally becoming and fulfilled in the way that people are supposed to be. Maybe the center of the universe, the thing that makes the universe special, is the presence of self-aware, able to love, able to recognize the existence of a God, able to do something about it. And that it's not that we're different from the rest of the universe, but that in those attributes, we and any other creatures, no matter how many tentacles that have those attributes, they are the reason for the universe existing. Chesterton, in a phrase someplace, says, a person is so big and the universe is so tiny. The universe the cosmos fits into your head. Recognizing that, nonetheless, we are the creatures that have the cosmos inside our head. By being aware, we are part of whatever it is in the universe that can be aware of the universe. And therefore, we shouldn't be afraid of the existence of others. And if we can communicate, just think of the stories we can share. What God loves in us, God also loves in the rest of the universe. And that doesn't dilute love. Love doesn't get diluted because I like you, but I also like him, therefore I don't like you as much. That's not the way that love works. By loving, by being the center of God's love, and being part of a universe that could well be filled, not only in space, but also in time. We've got, 14 billion years so far, and who knows how many in the future, where there could be other situations of a kind of life that we may not even recognize as life in a relationship with God. Should not fill us with fear, but rather, hey, that's us. We're part of that. I did that. I'm reminded in a funny way of what the people who worked in the Apollo program must have felt when Neil Armstrong walked on the moon, and they were able to say, and I was responsible for the bolt that went on the piece, that was necessary for it all to happen. We are part of this great adventure. The existence of other intelligences, I would say, raises an interesting challenge. Are we willing to accept the presence of others? Even as we're aware of the presence of God, are we jealous when we find other people who is in a relationship with God among human beings? I don't think so. I hope not. But also, intelligence only makes sense if you have someone to share it with. This is, of course, the lesson of science. If you're a scientist and you work in your basement and you never report to anyone the results of your work, you might just as well never have done it. If you're a scientist working in a field that nobody cites because nobody is interested, even if what you're doing is right, you're not communicating, you're not building the community of science. Maybe you'll be so lucky as somebody in the future might be able to use the results. But the fun of science is that it's done in community. The amazing thing about science is, do we have anybody here who's a published theologian? Okay. In your last article in theology, how many co-authors did you have? None. Is anybody here who's a scientist? Publishes in science. In your last scientific article, how many co-authors did you have?
3.
You see my point? Science is done, even though we're a bunch of social nerds who have no social skills, somehow we manage to work together well enough to publish papers together. Science is done in a community. I find a tremendous parallel between the world of science and the world of church. We always argue about the suits running things. We always argue about the overhead of having to deal with a big hierarchy and a big organization. But as I've often said, I work for many years with an outfit that's run by idiots that are terribly bureaucratic, that are totally out of touch with what the rest of us need or want, and yet NASA was the only outfit that was able to get us to the moon. And I have to recognize the validity of that I can't go to the moon by myself. And the miracle of the Apollo program was not the rockets, it was the politics that allowed 500,000 people to work together to build something that good, that quick. The other big question that I want to address involving astronomy is the question itself of cosmology. I talked about the 14 billion years, the origin. There's this book by Stephen Hawking and Leonard Nilsson, who, of course, you can find in really, really tiny print next to Steve Hawking. In the publicity for this, this is the quote they pulled. "Because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing. Why the universe exists, why we exist. It is not necessary to invoke God to light the blue touch paper and set the universe going." Great statement. Catches your address. A lot of Americans don't know what he means by blue touch paper. I think most of you get the idea. The fuse that sets things off. And of course, Stephen Hawking is famous for being one of the new atheists, even though there's not a whole lot new about what they're saying. And it'd be very easy, and it is very easy, and a lot of people have gone to great lengths to point out all the philosophical shortcomings. Most of these guys are elderly white males, and I've got nothing against elderly white males because I plan to be one myself someday, not now. Most of them are British, and I think there's something about the culture that had an established religion that makes a religion toxic to people. But there's also something about the education system that splits you off into a philosophy track or a science track at age 12. That means that people like Stephen Hawking have never had philosophy 101, which is a sad thing. But while it's easy to make fun of these guys, I think it's very important that we recognize that in this particular case, he's right. And he's right in a very important way. I'm stealing these ideas now from Bill Steger, who had a short article in a booklet we put together for the Year of Astronomy, which was condensed to a much larger and better article in a book called Creation and the God of Abraham, where you can no longer read the editors there, but look it up on Google. Very, very good book. And his point is this. You don't need God to set off the universe. In fact, you shouldn't need God to set off the universe. That's not what we mean by creation. Remind you a little bit about what Stephen Hawking and Leonard Malraux are talking about. 100 years ago last November, Albert Einstein published the theory of general relativity. And in this theory, he's talking about not only that space and time look different from different points of view, that was special relativity, but that one can look at accelerated situations and see gravity, for instance, as a warping of space and time. And if the universe is filled with an infinite number of stars and had existed for an infinite period of time, then one would expect that this warping would have warped the entire universe together. What's holding the stars out and stopping them from all collapsing in on themselves? And his answer was, I don't know. So he suggested maybe there's an energy I haven't heard of. Oh, I can fit it into this equation, and it's a constant, so when you try to do anything with it, it goes away. But that question really didn't even depend on general relativity. It goes back to Newton and Newton's view of the universe. Newton was the one who invented this concept of gravity as an action at a distance that allowed planets to be pulled into their orbits. When he was challenged, what is gravity? His only answer was, I feign no hypotheses. I don't know what it is. I can just tell you how it works. And that, in some ways, is the mantra of physical science. When you push them too far, you go, no, I don't know what it is. I'm not in the business of knowing what it is. I'm only in the business of telling you how it works, which can slide into the description of how it works is a complete description of what the thing is. Philosophical problem there. But Newton's laws, whether they're the law of gravity or the laws of motion, assumed a rigid framework, the inertial framework against which everything else is measured. And in itself, as we know from astronomy, the bigness of the universe, you have to ask yourself, all right, is the surface of the Earth the unmoving inertial framework? Well, of course not, because the Earth is moving. Is where the sun, is that the inertial rigid framework? Well, of course not, because the sun is moving in the galaxy. Is the galaxy the inertial framework against everything is measured? Well, no, because how are we to say that this galaxy is different? Is there some inertial framework that we cannot identify, but which underlies all of reality? And there was no way to prove or disprove that, but it was one of those philosophical questions that didn't matter if all you wanted to do was build a bridge. That change in cosmology, the idea that if you know the position and velocity of every point and the forces acting on it, you can then predict how the future is going to work, leads to the watchmaker and the watch view of the universe, where everything's a machine. And before, where we said the universe is determined by the gods in the heavens that move things around, and therefore it's all rigidly fixed by astrology, now everything is rigidly fixed by the mechanisms of the Newtonian forces against this rigid framework, and don't ask where the rigid framework comes from. Newton, of course, also was clever enough in measuring the positions of planets moving around the sun to realize that if the sun had gravity that moves a planet and the sun has gravity that moves this other planet, what about the effect of this planet on that planet, and shouldn't there come a time when the planets can disturb the beautiful and simple stability of the solar system? Since that hadn't happened if the universe was eternal, he deduced that the hand of God was holding the planets against these disturbances. And therefore, this was clearly a proof of the existence of God, what we now recognize as the God of the gaps. You know, 200 years later, Laplace works out a system doing the mathematics better than Newton ever could have done, shows that the solar system is stable. The story goes, when he tells this to Napoleon, Napoleon says, where's God in your book? And Laplace says, I have no need for that hypothesis. So God was a hypothesis, a kind of force in the universe that was no longer needed. This fits right into Michael Buckley's thesis in The Rise of Atheism, that when people attempted to use science and the gaps in science as evidence for the existence of God, as those gaps get closed, the need for God disappears and atheism becomes the only reasonable solution. Just as with Augustine talking about the things we know for sure from science, I'll point out that there are now theories for the early solar system that predict in the first 800 million years the planets themselves. Those are the four outer planets, and then all of the particles that didn't quite make a planet. So the red one goes Jupiter, then the blue one is Saturn, then the yellow one is Saturn, then the blue one is Neptune, then the purple one is Uranus. And you're going, wait a minute, that's not right. Watch what happens when suddenly they reach a mutual resonance period, and the planets aren't necessarily all that stable all the time. And yet here we are. Nonetheless, while Laplace is scientifically correct in saying he doesn't have that need for that hypothesis, I want to make the philosophical point that he's actually philosophically and theologically correct, that you shouldn't be counting on God to fill the gaps in your knowledge. Of course, even Laplace didn't know what gravity was. How many people here have tried learning classical Newtonian physics and got past, a high school course in it? Most of you. Do you remember what it was like the first time you encountered it? Anybody here tried teaching it? Newtonian physics, once you're used to it, is glorious and beautiful and logical, and it seems like it can explain everything, or should be able to explain everything. But boy, it is counterintuitive. It is really, really hard to bend your head around it. And the only way you can learn it is to live with it, and live with it, and live with it, until one day you go, oh, of course, that's how that works. Why was that so hard? Newtonian physics means that you have to adopt as assumptions a lot of things that are not intuitively obvious. It's lots of hard work. Ask any physics teacher, and there is a big gap between the way that most people wander through the world and the way that someone who is now immersed in the world of Newtonian physics sees the world. Classic example. If you show people a coiled up hose, and you turn on the water, and you see the water goes around and around and around and around and around, and you ask people who have not studied physics, what happens to the water when it comes out? an awful lot of people will think it continues to go around in a circle. Because after all, it's been trained to go around in a circle. Now, those of you who have studied Newtonian physics know what happens to the water when it comes out. Straight line. That's what's in all the books. All right, I dare you to stand next to that thing, turn on the water, and expect the water to come out in a straight line. You know darn well what's really going to happen. The hose is going to go flying all over the place, soaking you and everybody around you. Does this mean Newtonian physics is not correct? No. In principle, you could work out all of the forces of all of the bits of hose and the elasticity and everything else and calculate, but it would be a calculation as complicated and maybe more complicated than the epicycles of the Ptolemaic system. Even the Newtonian system is simple only in an oversimplified case. To argue that Newton is correct in describing the hose might be true, but it isn't practical. And it begs the question of whether it's a superior description to just throwing in a random number generator. So that's one of the reasons why Newton's ideas were so controversial and so difficult, because after you've gotten yourself thinking in this non-intuitive, well, Newton's physics works except for all the other reasons where it doesn't work, and that's because I'm neglecting all the forces that makes it not work. After you finally have bent your brain into a Newton physics way of looking at the universe, which makes you as normal a person as Sheldon in the Big Bang Theory, then you have to throw all of that away for a new way of looking at a universe which explains why a galaxy here can have streaks of light which are the gravitational focusing caused by the bending of space-time by the gravity of the object here to bend the light coming from an object behind. And I know very few people, I know a lot of people who study general relativity. I know very few of them who think in general relativity. I know a lot of people who have studied quantum physics. I know very few who can think in quantum physics. And in a way that an engineer can see how things are going to work because they've solved a million physics problems, they can see how things are going to work in a general relativity case without doing the calculations. It is a wildly counterintuitive way of viewing the universe. And yet it works. And it works such that you can actually observe its effects. There's going to be an eclipse of the sun next year, August 20th, I think, August 17th, 2017, or August 20th. It's middle of August. You can now buy a little telescope. Come on in, let the guy in. Yes, this.
Who is the guy?
You're welcome. This clerical guy in the back wants to come in and say hi. You can get a telescope yourself. Look at the eclipse yourself with a CCD camera. Measure during the darkness of the eclipse the position of stars next to the sun. Compare those positions before and where they are in the star charts, and you will be able to measure to a higher accuracy than Eddington the bending that comes from general relativity. You can see that yourself now. But if general relativity is true, what does this say about the nature of the universe? Einstein proposed that there was this energy holding things out to stop the bending from bending everything into one point. A mathematician at Louvain who could read equations like you might be able to read poetry, looking at the equations of general relativity, says, you know, in these equations there's a possibility of an expanding universe, and if the universe is expanding now, number one, we ought to be able to observe that, and number two, there must have been a time when all of the universe and all of its energy was in a smaller volume, and therefore the energy density was higher, and there's no reason to not go back to a point at a time that's a finite time when the energy density of the universe is infinite. And we know from quantum theory that energy drops in quanta. It's not just a smooth, so this would be sort of an infinite quantum state. And this was a theory that was roundly rejected by an awful lot of the astronomers of the day because, number one, it contradicted their assumption that the universe is infinite in space and time. It contradicted their assumption, the cosmological assumption, that what's going on here is the same physics-wise as what's going on anywhere else. They didn't like the idea of a universe with a beginning, especially since the guy who invented it was Georges Lemaitre, who happened to be a Catholic priest. And so Fred Hoyle on the BBC, making fun of these crazy ideas. He had his own crazy idea after they discovered the universe really was expanding. He calls this variant of the universe the Big Bang theory. And he invented the name as a name of mockery. 8 years later, he's at the Vatican for a big meeting, a scientific meeting sponsored by the Vatican Observatory. He and Georges Lemaitre run into each other, and they instantly become best of friends. And in fact, they share a car and spend a month on vacation driving through, Hoyle and his wife and Lemaitre, driving through Switzerland, taking Lemaitre back to Belgium. Because Hoyle was a good scientist. Hoyle had an alternate theory, and he said, you can test it. If my theory is true, this will be true. There'll be, if your theory is true, then we ought to be able to see black body radiation from the Big Bang. And we found the black body radiation. And Hoyle admitted there was a Big Bang. That's the way science is supposed to work. There was, of course, the temptation to say that the Big Bang therefore proves the Genesis point. In 1951, Pope Pius XII gave a talk to the Pontifical Academy of Sciences saying, isn't it interesting that we now have a finite age to the age of the Earth, about 4.5 billion years? Isn't it interesting that they're even talking about a finite age to the universe? There was a creation point, and with a creation point, why not a creator? Georges Lemaitre, Catholic priest, inventor of the Big Bang theory, rushes to see Pius XII to tell him, don't say that. Number one, maybe my theory's wrong. You don't want it, you don't want the Big Bang declared Catholic dogma. And number two, that's not what we mean by creation. Okay, let's go back to Hawking and Leonard. What they were saying is that we don't need God to start the universe, because in quantum theory, if there is nothing, if there is a vacuum, there is still a zero-point energy to that vacuum. It's a form of gravity, and that there can be quantum fluctuations. And if you wait long enough, and we've got all the time in the universe, a time should come when a quantum fluctuation suddenly creates enough energy to start off a universe. That would be the Big Bang. Don't trust me that I've got that right. That's the best I've understood of other people explaining to me what he said. As I say, that's a little bit outside my field. It is, of course, the God of the gaps. What's wrong with the God of the gaps? What's wrong with the God of intelligent design? Well, remember, back in ancient Rome, people had explanations that worked perfectly well for why things occur. Why is there lightning? Because Zeus throws the bolts. Why are there crops? Because Ceres causes the crops to grow. If everything that occurs in nature occurs because of the choice, or worse yet, the whim of a nature god, then there is no room for science. But on the other hand, I've been able to explain everything that occurs. The universe is like the cat coming to your door. And if it doesn't behave the same way 2 days in a row, well, cats are like that. Christianity comes along and it's persecuted by the Romans because they think it's a form of atheism, because we refuse to believe in the Roman gods. We refuse to believe in the nature gods. I only believe in one more God than Stephen Hawking does. I'm almost an atheist. We're not that far apart. If you're asking God to be responsible for the Big Bang, you're turning God into one of the nature gods. And it's no different than saying God was responsible for the human eye. I mean, the problem with intelligent design is, if God created this, does that say that he didn't create that? It's got to be all or nothing. You can't say this was designed and that wasn't designed. There is another problem with the God of the gaps. The mechanistic God that Newton was trying to invent is clearly, the watchmaker God, is clearly not the God of Scripture. Not a God that you can have a personal relationship with. It's a deist God. And a universe with only a deist God is, in fact, you know, it's like if God is your father, he's a deadbeat dad. He started you off and then took off. A God that is in the universe as a piece of mechanism is not a God that can give meaning to the universe. And the great philosophers who have rejected God have come to that. You know, the wonderful statement from Steven Weinberg. See if I... The more the universe seems comprehensible, the more it seems pointless. Bertrand Russell, we need to build a philosophy on the firm foundation of unyielding despair. This is where modern science has led us, to unyielding despair, to a meaningless universe. Well, I'm now going to steal from Reverend Sachs. Hold up the book. This is a book, it's called The Grand Design.
Oh, the Great Partnership.
The Great Partnership. The Grand Design was the other one. Great Partnership. Rabbi Sachs, at one time the retired chief rabbi in England, in there has a new translation of a familiar phrase from Scripture. Meaningless, meaningless, says the teacher, utterly meaningless. Everything is meaningless. Man's fate is like that of the animals. The same fate awaits them both. As one dies, so dies the other. All have the same breath. Man has no advantage over the animal. Everything is meaningless. You recognize the source. Vanity of vanities. It's not an idea that comes from modern science. It's an idea that comes from classic and very good philosophy, restated by Wittgenstein. The sense of the world, the meaning of the world, must lie outside the world. We must believe in a God who is not a nature God, but a supernatural God. And so, evoking science to prove a God would not prove a God that I believe in. It's essential to remember the kind of God we're trying to find. The God of Revelation is a God of beauty, of joy, of love, the way, the truth, the life. A God who can only be experienced. If you could prove God from scientific analysis, then the analysis would be greater than God. It works the other way around. We have faith to do science because we believe in a universe that plays fair. Because we believe in a universe that's created by someone who plays fair and wants us to understand it. And that's why I have the courage to do science. Only a supernatural God, only a God outside of nature can give our lives meaning. Only a God who is outside of Newton's mechanistic laws can account for things that the laws cannot account for, like beauty, like truth, like love. Only that kind of God would be worthy of our adoration. Now, I'm going to skip that. I'll end with this point. When Stephen Hawking says that the universe doesn't need God because the universe, the Big Bang, occurred because of a quantum fluctuation in the gravity field, he's guilty of terrible logic. He says, I define God as that which started off the universe. He then says that gravity is that which started off the universe. Therefore, God is gravity. Which maybe that's why he thinks Catholics celebrate Mass. And I'll end with, the whole new cosmology. Actually, I'm going to end with the one essential point. Our idea of creation out of nothing, which incidentally comes from the book of Maccabees, and it's not a deep philosophical point. It's a mom encouraging her kids, saying, don't worry about what's going to happen to you, because the God who's looking over you is the God who made the universe out of nothing. Most of the really profound things come out of people saying what they think is obvious and no one else had ever said before. By nothing, we do not mean vacuum. We mean the absence of space and time itself. And that means that the Creator God, who exists outside of space and outside of time, that solves a lot of the paradoxes. If God is all-knowing, does he know the future? God remembers the future. He didn't cause the future any more than I caused John Wilkes Booth to shoot Abraham Lincoln. If God is outside and transcendent, he's also immanent. And that is the joy and the magic of the God that we know we believe in, the God that we experience. And the God who is outside of the universe and yet chose to exist in Jesus Christ, as Jesus Christ, in a space, in a time, in a particular. And once you appreciate that, which I think you can only come to an appreciation of by knowing the physics behind it, then I think this does give you a richer understanding. If nothing else, looking at the ginormity of the universe compared to the flat Earth with the dome. Flat Earth with the dome is pretty darn big. Go outside and take a look at it. Bigger than that is the God who made it. A universe that's the sun and all the planets. Bigger than that is the God who made it. A universe of all the stars in our galaxy. Bigger than that. A universe of 13.8 billion light years. And bigger than that is the God who made it. So either I'm so tiny that God can't possibly notice me, or God is so big that even in that enormity, God does know and love me. And it's your choice which God you want to believe in. So, thank you very much, and Michael, come on up.